I showed my handbook. Here, give the handbook away. So I figured I'd do that. Over a few years before. You were in focus. There were a couple.
I went over to the other building. I went to work for my son.
I occasionally mess around with it. Not there.
You got my... Sorry, I didn't get to it.
No, you're fine.
I saw it and then I was on the run.
Unmuted.
All right.
Actually, Kevin, hang on, let me record.
Recording in progress.
Good morning, everyone. So good to see all of you. I've gotten around to shake most of your hands, but some of you that just came in, I've missed you. All right. Before we get started, I'm going to break protocol a bit. Who is here for a first time since getting their amateur radio license? Anyone? Right over here. Stand up and tell us who you are.
I'm Burnett Stocking. My call sign is Kilo Kilo 7 November Kilo Kilo. So
All right, where's home?
North Logan.
North Logan, all right. Who else is from North Logan here? I got one is all, huh? What are they all doing? Sleeping in, or is there a breakfast we don't know about? All right. North Logan. I guess, Phil, you're Hyde Park, huh? Yeah, close enough. All right, well, welcome. We're glad you're here. Please bug us and ask questions. Anything we can do to help you jump into the hobby or be successful. Anybody else here for the first time? Okay, I'm going to pick on a couple. You two in the back. I don't know your name, so that means others don't. No, behind.
We do. We just went over this.
I know we did. Those two.
I'm Mike Bohm. My wife Katie. We don't have a license. We're just getting into the hobby. And
Cool. You're in the right place.
trying to check it out. See what's
What was the names again?
Mike and Katie Bohm.
Which city do you live in?
Nibley.
Okay, what's your
I was sheriff's deputy for 8 years, and then my boys are military, so and then we do a lot of hiking camping, so I decided it'd be kind of fun to get into and
Yeah.
get prepared.
Our radio on Mount Logan covers all that backcountry. All right, where's Kim Owen? Where are you, Kim? Right back there. Kim, you got a new couple from Nibley right there. So connect with Kim. He'll be a great ally. And connect with any of us if you need some help getting in. All right, anybody here upgrade their license in the last, since we have, I guess November would be our last club meeting, although the Christmas party. Anybody upgrade? Okay, what's that?
Tyler's about to.
Oh, Tyler's about to, okay. And Gavin is about to, right?
Oh, no, I already did.
That, you did? Your general? When did you do it?
A couple of weeks ago online.
Hey, let's give Gavin a hand. You may remember Gavin won that pretty sweet DX10 radio at the club meeting. All right. We've got a great club meeting tonight. First of all, I'm going to turn it over to Tyler, who is this year's vice president, right?
I think.
Yeah. My right-hand person keeps me, I have ADHD, so he keeps me remembering what we're supposed to do next. So
And it's morning, not night.
it is morning. Did I say good evening? All right. All right. Good morning. Anyway, I did have a good night's sleep. We'll turn it over to Tyler for announcements.
Okay, just a reminder, it's time to up your dues if you haven't already done it. Our dues run from January through December, so it's time. Club officers for this year, everybody knows Kevin. We have myself as the vice president. Tammy, where are you at? Raise your hand. Tammy is the secretary. Richard is the treasurer. And then we have Spencer as a board member. Dave Kavanaugh, I don't think he was going to be here today. Jordan Luke.
My call sign's wrong up there.
It's kind of close.
Right off the website, you might have it wrong.
It's KF7YEM.
That's probably my fault.
I don't know.
I may have screwed it up in the newsletter.
It might have been in the, so I might have cut and pasted it from the newsletter. Joseph Longhurst and Ted MacArthur is all board members for this next year. License exams. Richard, give you a minute.
All right, for those that are looking to get their license, we have a test session 2 weeks from today in this room at 8 a.m. And then we have one, also in February, we have a one-day technician class on February 15th, and then the exam session will follow at 3 o'clock. Have any questions, come and find me, and I'll get you some help.
Yeah. Also, we have upcoming one-day class. You want to talk about that, Ted?
All right, so for those of you that know somebody or you want to get a little refresher just before you take the test, on February 15th, we have a one-day ham class. Starts at 8 a.m. and we go through every question on the technician test, and then will finish sometime close to 3 o'clock, and the VE, the guys that come and do the testing, will be here at 3, and you take your test. We have really good results, but you need to study some before you come. Get familiar with it, and then we usually have in the high 90s percentile of passing that. So please come. If you go to the club website under Get Your License, there's a place to click and have you sign up so we know how many we're going to have, and that will be right here in these rooms here.
And if you need a flyer, I have a few flyers. I didn't print out a whole bunch, but there are some flyers on the one-day ham class, and I'll leave them up here if anybody wants one. Ted?
Okay, every other month, every odd month, we have an Aries meeting on the third Tuesday. And this month on the 21st at 6:30, also either in this room or on the second floor, we will have weather spotter training from John Wilson from National Weather Service. And it's open to everyone, not just hams. Anybody, if you got people in your church or friends that are interested, I've had them call me sometimes when we get a bad weather happening. If you're on this list, they'll call you and say, hey, what's it doing? And they really like to know, like hail or certain weather patterns that are happening that helps them give better forecasts. And this, I think you have to renew it like every 2 years, but would like to see a big turnout and come up and learn what they're looking for, and you'll get on their list. And you also can call in if you see some weather that you think would be important for the Weather Service to know about.
Yeah, they like having boots on the ground weather reports when it's really bad weather. So Elmer Night, the third Tuesday of even numbered months, we do an Elmer Night. So the next one is on February 18th at 6:30 p.m. If you're new or need help, it's really kind of like help desk night is what we ought to call it, but an Elmer is somebody that helps other hams. So if you need help, if you're new, you want information, need help programming a radio, this is your opportunity. Yeah, if you're old and need help too.
What if you're in the middle?
You probably need help too.
Okay.
BARC Online, have you got that ready to go? The activities?
Not yet.
So pretty soon this link will take you there, but it's not actually ready to go, but you can go in and sign up for activities. Hopefully pretty soon we'll get that online and ready to go.
Update the dates.
Yeah. I think most of the information's there, but not all the dates are correct for this year.
Don't sign up because we're going to delete it's last year's database of sign up.
So if you sign up, you might not get in there, but if you wait till we say, you can. So it will be coming up soon. The Utah Digital Communications Conference, you want to talk about that?
Sure. How many of you have been to the Utah Digital Communications Conference? Yeah. This is coming up February 22nd. This is the date when the VHF Society swap meet used to be, but they've had to move theirs to March. And so we've taken this date, and they're a co-sponsor of this event. The swap meet will be in March. But this is a really good come and learn event from experts who are outstanding in their field. I don't know which field they're standing in, but they're pretty good. We have a few of our club members that will be presenting. It's for beginners and experts. There's about 100, last year about 175-ish attended. There will be like 18 different presentations. This year there'll be 2 main ones in the morning and then a breakout session. It's a really cheap to attend. It's like $15 if you sign up now. That just pays for, we rent a conference center. I'm one of the co-organizers. This is the 9th year. And so if you're interested in learning more about ham radio, come out. There'll be sessions on a wide variety of topics. The theme this year is emergency communications, but we have some non-emergency ones as well. So we've got John Lloyd, who's going to show people how you tune duplexers for repeaters and go through that process. Tyler here is going to show you how to set up a portable WinLink gateway for emergency email messages and things like that. So another one about citizen science and SDR. The list of presentations will get published soon. So you can go out to utah.dcc.com and that will take you to the site. So if you're around, it's a good conference to come down to Salt Lake and join.
Thank you, Kevin. BARC, we are on Facebook, so join there. I forgot to update Facebook till this morning about the club meeting, but I did get it in there. Also, we have an email list where most of our information comes out. Join this list to keep updated on what we're doing and what's happening. A lot of information, maybe too much information sometimes, but there's a lot of information that comes out there. Notifications for all the nets and club meetings and stuff come through there. Some other announcements, like we had the communications conference. The VHF Society SWAT meet is coming up on March 29th. That's down at the Legacy Event Center. That's always a good time to pick up new used equipment, bring and sell equipment, so it'll be a good one. There'll be more information on that one. If you've been there before, it's in this, I think it's in the same building it's always been in down there at the Legacy Event Center. We have the BARC Ladies Net on the 2nd and 4th Tuesdays on the BARC repeater system at 8 p.m. We have a VHF single sideband net on 144.200 on upper sideband on Thursdays at 9. And we have the Northern Utah Technical Society, or the NUTS. We're all nuts to do that. But it's a D-Star net on Sundays at 8 p.m. on reflector 029 Charlie or our local D-Star repeaters. So, Russ, do you want to come up and talk about these? I think I got these in here right.
Off the new page?
Yeah.
Okay. So we've been talking about this quite a bit lately. So there's a lot of different posts and announcements if you look on the message group and net announcements and stuff. What these are is the elementary schools in Cache County have started, almost all of them do STEM fairs now for their communities. Different businesses or clubs like ours have a table there where we do something fun and try and teach some science to the kids and have a fun family night. So they're really fun events. We have a table where we have several different projects we've been putting together. We also got a lot of grant money that we have a lot of work to do this year. But anyway, you don't have to have any particular experience to come. Especially if it's in your neighborhood, if it's in your community, go and sign up for that one. Come on out and help at our table. We'll teach you everything you need to know and how to talk to the kids and teach the things that we're doing there. And along with that, we just launched a new youth page on the club website that covers all sorts of STEM type activities that the club has been doing, whether it's mentoring opportunities for club members or youth activities, especially youth on the air activities. We're starting up, Jordan is starting up a whole youth on the air program as well. We're trying to do more for the youth in ham radio in Cache Valley. So stop by that new page. It's under the activities menu, and come out with us. It's a lot of fun.
Thank you. Now we'll turn this over to Jordan for a minute for his little STEM stuff.
So I had a person from Science Unwrapped. This is put on by the College of Science up at USU. They're one a month. They're usually on a Friday. I think actually all of them are on Fridays. So this is going to be similar to what we do with the STEM fairs that we go into the elementaries, but this one's always going to be at the same location, same place. And we have 4 this year. I will sign us up next year, and so we'll have all of them as well as next year. But once again, this is just to have someone come out, sit at the table with the stuff. This event is a little bit different than the elementaries, because you'll have an audience ranging from adults to kids and a number of the college students. The forum is set up such that they have a guest speaker usually come in and talk about something sciencey that they're working on. And then they open up into kind of an open house with all of the different people around, different businesses showing with some hands-on things for kids and for even adults. They'll have some things there for them. And there's also refreshments served by the College of Engineering, so you can come in here, present and get a snack. And once again, we have a sign-up page on the youth. I put it there just because I feel like it fits really well with there. We'll be using the same kit and everything. So if you just want to go in and sign up, and you just show up just shortly before 7, help get everything set up, and listen to the speaker, and then get more people interested in ham radio and what we do here.
Thank you, Jordan. So now, unless Kevin has anything else, we'll turn it over to...
One thing. Help us spread the word on like the storm spotters. Many of you have city nets and other things. Help us spread the word about Utah DCC on the nets that you run. These activities help us spread the word. The club exists not to have members, okay? The club exists to promote the hobby and help people who are interested in the hobby learn more. Very few people can learn the hobby on their own. We all need to be mentors. But anyway, all right.
Okay, well, we'll turn it over to Kelby. Our club has this rig expert antenna analyzer, and he's going to show us everything about it.
Not everything.
Well, enough to get you well confused. It's really a pretty simple one to use. So anyway, over to you, Kelby.
Can we put a mic on him from the PA? Is there one?
I can't remember which mic we have to use. One then, one back there.
This mic doesn't go into the PA?
No.
Oh.
Where does yours go?
Test. Try that one. Nope, that's not it either.
Go ahead and type camera again. Oh, there it is right there.
One more, Kelby.
Okay, how's that sound? I've been interested in amateur radio since I was about 12 years old, and I've been licensed for 33 years. But I'm one of these weird guys who don't like to talk on the radio. I'd rather tinker with an antenna. And I worked for the Space Dynamics Laboratory for 45 years, and at the time I retired, there were 4 satellites in orbit with my antennas on board. Kevin asked me to describe this Rig Expert antenna analyzer. Let's see if I can make that show up a little better. That's better. Okay. When you first turn it on, you'll be presented with this main menu. And I'll describe each one of these features: a Smith chart, SWR chart, RX chart, all parameters, setup, calibrate, RL chart, multi-SWR, and tools. First of all, The Smith chart is probably not one that a lot of people would be interested in. Well, let me show the buttons first. Anytime you press this cancel button, it'll bring up the main menu. And anytime you want to initiate an action, you press this OK checkmark button. And some of those, almost all of those menu functions that I just showed you are also available on the keypad. If we select the Smith chart, it brings up this polar coordinate chart, and like I said, probably most people are not going to be too interested in using that. You can also bring it up by pressing the polar key, number 2.
Yes.
Now let's see if I can change the, whoops, the brightness.
Get some light on it. There you go.
That way you'll be able to see.
We'll be able to see the screen and not the instrument.
Don't turn on this one. The second row. There you go.
Okay.
Sort of.
The SWR chart, this is the one that you'll
Turn
be
that one on and that one off.
interested in looking at. And that can also be, you can select it from the main menu, or you can select it by pressing the keypad number 4. And when it first comes up, nothing's happening. So in order to instigate a scan, you have to press the OK checkmark button. And I have programmed into the unit to look for the 14.074 frequency. This is on 20 meters. That's what my antenna is set up for. And that happens to be the FT8 favorite frequency. For other bands, you would put in a different frequency, and I'll show you how to do that. But you can see that my frequency is a little bit off. The center frequency set right here is displayed up here, and the minimum SWR is displayed down here, and the minimum is at 14.13. So if I wanted to tune that up a little better, I would adjust my antenna.
Is that dynamic? Does it update?
No,
you have to run a sweep.
You have to run a sweep, but you can put it in a recurrent sweep by pressing the F and the OK. It sweeps kind of slow, but it continues over and over. And you can see I'm tuning in my antenna there.
Bingo.
So and you notice it moved when I move away from it. Yep. Okay. If you want to change the frequency and look at a different band, you come down here and use this frequency range button, number 3. You'll bring up this, and the cursor, where the cursor's blinking is where the number will change when you select a key. And say we want to tune a 40 meter antenna, we would press 0 on that one, and 0 on that one, and 7 on that one. If you want to and then it'll move down. The top frequency is in kilohertz, but you just move the decimal places over 3 places and it's megahertz. So that's 7.5 megahertz. And then this field right here is the spread that you want to look at. They don't give you a start and a stop frequency. They give you a spread. And this would be 1 megahertz spread. If we want to look from maybe 6 to 8 megahertz, we would come over here and put a 2 in there.
That would give you a
4 megahertz. Okay. And my antenna is not tuned for this band, so we're not going to see anything, but that would sweep 2 megahertz, about 7.5. If we want to look at a 2 meter antenna, and they don't seem to be tuned up. Yeah, maybe we'll expand the range a little bit.
It's too long.
I'm not seeing a dip anywhere.
A little shorter. Shorter. Its resonance is too high. Oh, no, you're right. Yeah, it needs to be longer.
Okay, there we got a curve. Notice it's This little triangle down here is pointing at the minimum SWR, and it's 1.21, which is good, and it's at 145 megahertz. If we want to, if your goal is to set it at 146 megahertz, we've got to shorten it a little bit.
It's amazing what a difference an inch makes.
Yeah, especially at this frequency. That's pretty good. Another feature of this device is you can measure your coax. I'll just take it off and use the TDR chart. This one takes a little longer. And this tells me that my coax is 21.17 feet long. And I know that that's exact because I measured it with a tape measure. And now I'm going to put an impedance bump in it. See, it's about this far from the end. This could represent a pinched coax or a loose connector or something like that. And we'll run this same.
So Kelby, you might explain what it's measuring. You know, tangent magnetometer, what that does.
It's sending a signal down the length of the coax, and it reflects off the end and comes back. And then it takes those two measurements and does a complicated mathematical calculation to determine the length. And it involves the impedance of the coax and the velocity factor. The velocity factor is the characteristic of the materials that the coax is made out of, which slows the speed of an electrical signal through the wire. It'll always travel slower through the wire than it does through space. Okay, now you'll notice that that little peak at 21.7 is the same as before. And if we scroll over here, it says that bump there is at 15.52, and that's exactly the place where I put my impedance bump in my transmission line.
Where do you put in the velocity factor?
That is in the setup. Cable velocity factor. And it defaulted to that 0.66, which happens to be the velocity factor of RG58, which is the coax that I'm using. If you're using a different transmission line, you would want to change that to the published spec.
So TDRs I've worked with before, coaxes, and I couldn't figure out how you tell that.
You can do that. This unit will do that. To measure the impedance, use a piece of open circuited cable, a half of a meter or a foot or longer should be fine. And I think we use the
You need to take your thing off your coax.
yeah. Go into the tools. The tools is this 8 button, but you have to do the function button. Function 8 brings up the tools chart, and there's the cable impedance. And I'll take my impedance bump out.
Does that require you also to have the right velocity factor?
Yes. There are different functions. This unit will allow you to discover the velocity factor by measuring the cable length and running the test, and you can determine what the velocity factor is. There's instructions in the manual how to do that. So it says connect an open circuit cable and press the start key. And then we put a short circuit in the end of the cable. Press the start key. Unfortunately, when you borrow this unit, all these little things that I'm plugging into the cable don't exist in the box. Yep. Okay, now that's kind of a ratty looking plot, but it's sweeping from 0 to 600 megahertz. We're just interested probably down here at 50 megahertz or less, and you can see that it's reading 53.4 ohms. That's the cable impedance. And it actually changes with frequency. So now it's 46, 52, 48. Anyway, based on those numbers that it's displaying, you'd call that a 50 ohm coax. Yes?
So technically, we might just mention that the theoretical impedance of a coax cable is only dependent upon the geometry and not on anything else. So we see the difference between the theory and the actual application in this graph. It's an interesting graph to actually see.
The spacing on a 50 ohm coax, the ratio of the spacing is a little bit different than the spacing in a cable TV coax. Cable television coax is 70, 75 ohms, and most radio transmission lines are 50 ohms. Okay, we'll go back to, well, let's do a cable loss experiment here. You can see that at 321 megahertz, the loss is rather high, 1.25. But if we get down here (25 megahertz), that's not too bad. It's a half a dB. If you were interested in using this transmission line for a 2-meter antenna, 148 megahertz, the loss is 1.34.
Is that loss per meter?
No, that's total loss of the cable, the length of the cable.
Is that, you have to put the short or something on it, or is that open?
No, it's open right now. Let me look at the, okay. We do the open first and then the shorted, and it'll give us a better measurement. I did that backwards. Now we'll put the short.
Does the rig expert remember previous tests? If you power it off and power it on, you're going in and seeing values from a previous test run?
No, but it has storage locations and you can store test experiments in a memory location and recall them. Okay, there. We are looking at 2.2. Pretty much the same. Whoops. I just lost it. Pushed the wrong button. If your cable loss approaches 3 dB, that would not be a good transmission line for your 2-meter or your 440 antenna, because you'll be losing half of your transmitted power before it gets to the antenna. This one's 25 feet.
So we had a 50 be,
Half an hour.
it would be almost 3 dB.
Yeah. Mhm. Okay, now if I push the correct button. (148 megahertz). This is 1.36 dB. It's not too bad, but it's not the best.
Compare it to a larger, we got a short piece in here.
A short piece of.
It's probably 213 or something.
Yeah, if you want to. Scroll over how far?
To 440, I just want
To 440? Okay.
It looks like it's flattened out there.
Well,
It just tops out.
it tops out. Let me see if I can compress the let's see here. There.
I think you wanted to show your graph.
Now we go over to 440. .85. But that's in the dip. See, right there, it's 3.58.
8X. I don't know if we have adapters though.
I do.
Okay. You have one for your short one.
Yes, I think I can do that too.
Not quite as long a cable though.
What kind of connector is on that? Is that an N?
It's an N.
But in the box, we have an N to PL259. Is there any others?
No. I've been using the N to BNC because my cables have BNC.
Put this back in here.
Well, I just moved it.
So it's open.
It's open now. And then we'll need a short. Is that first scan completed? Asking for a short.
Yeah, connect to short.
Okay. This cable's not going to have a lot of loss because it's so short.
Yeah.
Oh, that's interesting. Oh, I keep pushing the wrong button. The left scroll button is right by the start button. I want to push the left scroll button, I push the start button and have to start over again. Okay, now at 440, .35 dBs, but right next to it at 431, we've got 1.82 dB. This short piece of coax has probably multiples of half wave and quarter wave lengths at these frequencies, and that's what's making those peaks. And a quarter wave transmission line works as a impedance transformer. It'll transform a high impedance to a low impedance. A half wave transmission line will mirror the impedance that it sees on one end to the other end, and it doesn't matter what the impedance of the cable is. But I think we're seeing the effects of multiples of quarter wave lengths in this short piece of coax, and that's what is making the peaks in that graph.
If you were to check the frequency of that very first peak, you could probably figure out the resonant frequency of the cable.
Yeah. .231 megahertz.
Turn that into meters and
Okay, let's look back at the menu. We've done cable impedance, we've done cable loss. If you ever wonder if the instrument is working, there's a self-test suite that you can instigate, and it'll go through and check the functions of the unit. A stub tuner. Some antenna experts like to build phased arrays, or they'll connect more than one antenna together to stack them, and they connect them together with specified lengths of transmission line. And this function here, this stub tuner, is a function that lets you precisely measure the lengths of these stubs that you connect these antenna arrays or multiple antennas with. Multi-SWR, if you have a multi-band antenna, you can put the frequencies of the different bands in these slots, and measure all 5 SWRs at the same time. So if you're adjusting your wire antenna with traps or that's about the best example I can think of. A log periodic antenna might find some value with this function here.
Can you show just the simple SWR reading?
I don't have a multi-band antenna.
No, not.
Oh, yeah. Oh, I see what you mean. Yes. SDR meter. Let me put in my frequency again. And hook up my transmission line again. Okay, I've got my unit tuned to 14.074 megahertz and we're reading an SWR of 2. And this function is useful if you're trying to tune an antenna. You can see how that might work. As I increase the capacitance on my capacitor, the SWR gets better. And I've run out of tuning range, so that's the best it's going to get right now at this frequency. If we go to the SWR chart, it'll show the minimum SWR at 14.07, that's pretty close. If you want to spread that out some more, okay, let's look. An RX chart, not too useful for most people. What's that showing? Let's see. The black trace is the resistance of the impedance, which is this trace with the hump, and the reactance is this lighter trace, and any place the reactance goes through this 0 axis, that shows the actual resonant frequency of your antenna. And typically when you're tuning an antenna, looking at SWR, that's good enough. If you get a good SWR that your transmitter is happy with, you don't really need to worry about anything else. But the point of minimum SWR might not be the resonant point of the antenna. But it doesn't matter. If you're curious about the resonant point of the antenna, you have to look at either this RX chart where the reactance goes through 0, it does this, or a Smith chart will give you the same information. If you want to look at the Smith chart, right, let's see.
All right, Kelby, I got a question for you.
Okay, just a minute, let me finish my thought here. This is the point we were looking at just a minute ago. You can see that that's the minimum SWR at the frequency that we're looking at. The actual resonant frequency is here or here. Question, Kevin.
All right, so let's say I got a coax that's got 3 dB loss. At, let's say we're at the 440,
Okay.
That's half my signal, correct?
Yep.
So if I was putting out 100 watts from my radio, that now means 50 watts.
That's your antenna.
Okay, let's say my antenna has 3 dB gain.
Then you're back to square one.
I'm back to 100.
Yeah.
If I have a 6 dB gain antenna, then I'm back to square one plus another?
Plus another 3 dB.
200 watts.
So as if I had 200 watts, that's correct?
Yeah. Well, you'd add, yeah.
At the antenna, obviously losing some directional, more directional.
Yeah. Keep in mind that an antenna cannot create gain. It can only modify the radiation pattern. So if it's putting more power in one direction, it's taking it away from another direction. Yes?
And the importance of the reactance is in designing an antenna. You need to know if you need to add or subtract capacitive reactance or inductive reactance. That's why the RX chart is useful.
Yeah. An antenna that's too short or too long will have either capacitive reactance or inductive reactance, depending on whether it's too long or too short. If it's small, if that reactance is small, it really doesn't matter. And you can look and see what it is by looking at the Smith chart or the RX chart. And you can read those. And if you're really fussy and you want to tune out that reactance, you can do it. If it's inductively reactance, you can add a little bit of capacitance to your circuit to tune it out. But you're not going to hear a difference on your signal unless your SWR is outrageous. Any other questions? Should we look at more?
So Kelby, on receive, does the same apply? If I've got a SWR that's dropping 3 dB gain, is that affecting my receive as well?
Yep. Yeah. Yeah, it's impedance in your transmission line. Let's look at the Smith chart, SWR chart, RX chart, meter, all parameters. This all parameters is a chart that gives you the numbers if you're interested. SWR impedance 59 ohms. The resistive impedance is 58 ohms and the inductive reactance is 14 ohms. Return loss 15.7 and the phase. Phase isn't important until you start trying to phase multiple antennas, like multiple verticals in a phased array. That's where the phase figure would come into play. Gets complicated. The calibrate, say you're working on a wire antenna, like a dipole or an offset feed wire antenna. And the unit in its power on state, the measurement plane is right here. So it's going to measure your antenna plus all of the coax that you have connected to it. You might be interested in what the actual impedance of the antenna is without the coax. And that's kind of difficult unless you've got a big tall ladder sometimes. But you can take your transmission line, disconnect it from your antenna, and use this calibrate function. I keep hitting the buttons on my camera here. You can use this calibrate function, and you have to have a short and a load that matches the connector on your coax. And it'll walk you through the process to calibrate. It'll have you run a scan with the open end, then it'll ask you to put the short on and run another scan, and then it'll ask you to put a load on, and that load has to match the impedance of your coax. And at that point, the measurement plane is here on the end of your coax instead of here at your analyzer. Then you can measure your antenna and you can be confident that you're measuring the actual impedance of your antenna minus whatever effects the coax might have. If your antenna is not 50 ohms, say it's 200 ohms, and you happen to pick a coax length that's a quarter wavelength, it's going to take that 200 ohms and it's going to change it to something totally different than you expect as far as impedance. If you put a half-wave coax on it, it'll show up as 200 ohms on the end of your coax because your antenna is 200 ohms. So the length of your coax can affect the impedance of your antenna system, And usually you're measuring on the end of your coax, so if you're happy at that point, you're good. You don't really care about the rest of it. But if you do care, that's how you do it. That's how you measure it. Yeah.
What's your thoughts over this to a nano VNA?
Oh, this is easier to use. I brought my nano VNA. The nano VNA will do everything that the rig expert will do. I'll probably be demonstrating how fiddly it is to get the Nano VNA set up. The Nano VNA has 5 channels that you can program to measure different frequencies and different functions. And you can see 0, 1, 2, 3, 4. And so you've got to set one up. And then every channel you can set up to do a different function. Let's see here. Display marker. You notice down here, I'm scanning from 965 megahertz, which I don't want to do. So we have to go to the stimulus and do a start. And I'm going to start at 13 megahertz, and I'll stop at 15 megahertz. And one thing about the Nano VNA is you can display all 5 channels on the screen at the same time, which can be totally confusing. And the way you turn them off, there, I've turned off the blue one. See, I can turn off the yellow one or turn it back on. And there's the SWR notch that we were looking at with the rig expert. You see how it's moved over by changing the tuning. The Nano VNA can do the functions that the rig expert will do. It just takes a little more fiddling and how to get it set up. The rig expert that's sitting right there costs $600. The Nano VNA like this one is $100. There are smaller versions of the Nano VNA that has a smaller screen. You can get them for $50.
I don't recommend it. The screen's a pain in the butt to work with.
Yeah, I wouldn't recommend it. But these are really amazing. Years ago, vector network analyzer that would have this capability would be a lab-grade instrument, and it would cost $20,000 to $30,000 or more, depending on the capabilities. Okay?
Do you have to calibrate the Nano every time that you use it?
You do, unless you store the calibration in one of the channels.
Thank you.
Mm-hmm. That's a good point. You do have to calibrate the Nano VNA before you make a measurement, and you do it by the process that I described. You have to press the Let's see, where's my calibration? Cal, right there. You calibrate it, and then you have to do, you'd want to calibrate it if you have a short test lead that you're using. Otherwise, you have to hook your antenna right up to the instrument. Usually you'd want a 2 or 3 foot coax. And you put a open, press the button, then you put a short, and press that button, and then you'd put your load, your 50 ohm load, and press that button. The isolation and the through are necessary if you're going to do a measurement on a common mode choke or a filter. For antenna measurements, it's not necessary, and you can just press the done button. And it would be calibrated enough to do the typical antenna measurements that I demonstrated here today. Did I answer your question, Ted?
Yeah.
Okay. Yes?
And then if we go back in time, long before our integrated circuits, we did these kind of, we could only do some of these kind of measurements, like SWR, with a noise bridge.
Uh-huh.
And it was very, very tedious. So thanks to our modern electronics, like you were saying, something this size at this price would have been wonderful to have 50 years ago.
Yeah. Yeah. These little nano VNAs, they're amazing. It's kind of a steep learning curve to learn how to do them. And in fact, at DCC, I'm going to be presenting a session on the nano VNA entitled Getting Started, where I'm going to go through all the rigmarole of getting them set up and calibrated and how to set up the menus and everything. Is that good? Any more questions? Okay, I'll turn it back to Kevin.
Thank you, Kelby. That was good. I learned a ton, and I've used that antennalyzer a couple of times.
Domestic clubs.
Yeah, so here's what you need to know. That antenna analyzer does no good just sitting in that orange case. It was bought for the club members to use. So we are going to, as a board, we're going to find a caretaker for it that will be responsible to check it in and out, and we'll let you know. But please use it. Like I said, it does no good just collecting dust. We bought it, when did we buy it? A year ago, about? Less than a year? A year ago. Because then we had to send it back because Joseph found out when the keys wasn't working on it. And it took us a couple of months to get it back. The company's based out of Ukraine, but their repair center is Canada, or was it, yeah, Niagara Falls or something? So anyway, so it's here to use. And like I said, please feel free to check it out. All right, just one small item of club business. Just to where next month we'll be voting on the budget. The board will be working on the budget to get it ready for voting. It'll come out in the Ohmtown News. Let me tell you what we've done. We've been working on this for some time, but we have received permission from the sheriff's office to put a 40-foot container for storage on one of their properties here nearby. We are now shopping for a container because we are paying how much a year, Richard? About $1,200? About $1,200, about $100 a month for our storage unit, which started out at $70 and is now over $100, and we're supposed to be getting a good deal. People keep giving the club repeater stuff, racks and cases and consoles, and Jason's been able to get some computers. And then we have the portable repeaters and the digipeaters and the load adjust stuff and Bear 100 stuff and all kinds of stuff. So we're going to be looking for a good deal on a shipping container. If any of you have any insights into, we've started looking online. There's a couple of companies in the valley as well as Tremonton, but there might be a better deal somewhere else that you know about. So if you got any insights, let us know. We're looking for a 40-footer, and that'll give us plenty of storage room.
You do want a 40-foot?
Yes.
Okay. Do you guys want to buy it from someone that's transporting, or do you have transportation means, or?
Any ideas?
Well, it's whatever deal we can get. We don't have any way to transport it ourselves, but we do have some truck drivers that can drive it for us, but we don't. We'd have to get a way to load it, but we might be able to do that too.
I can get it up here. We just need a way to get it off. That's the only difference. Is so if we can figure out whatever, not that heavy, believe it or not, if we can get a front end loader, even to chain it and move it. If you guys can figure out that part, we can get it up here pretty easy.
Okay. Thank you. Let's make sure we have your contact info with Ted before you leave. But anyway, that's what we're going to do. It'll cost us a little bit up front. We're seeing 40-foot containers anywhere from $2,000 to $5,000, depending. We don't want one that leaks. We want one in good condition. We want to be good stewards. So we'll have that in the budget, but after about 3 years, we'll have it paid for, right? And we're thinking this is a good way to go on behalf of the club, and we do have the money for it. So anyway, look forward to that. We've got refreshments in the back. A reminder, if you did participate in Loadaja, I've got a stack of shirts that Brent gave us, a few, looks like about 10 or so. Come grab one. After about 20 minutes, if they're left, I'll give them to anybody. I don't need more shirts, Loadaja shirts. My closet is full of them. Anyway, thanks for coming, and look forward to visit with you.